All right, let's go ahead and get started. Before we talk about the problem that's on this page, I want to talk about what it says at the top, using the formula for the mean. And the idea here is on Tuesday, I gave you this formula for the mean, where the mean is the sum of the data points divided by the number of data points. So add them all up, divide by how many there are. That's how we find the mean. Well, I didn't think that would really be something you needed to find the mean of a data set, but it comes in handy for problems like this that don't immediately appear to be a mean type of question. Here's what I mean. A small used car lot carries an inventory of 20 cars. The mean value of the cars on this lot is $8,000. What is the sum of the values of the cars? At first glance, at first reading this, you're like, well, I don't know what the sum of all the values of the cars are. There are 20 different cars out here on this lot. I don't know what any individual car is worth. I have no idea. I don't know what the Dodge is worth. I don't know what the Toyota is worth. I don't know what the Hyundai is worth. How am I supposed to know the sum of the values of all the cars? And here's how. I don't need to know the value of any individual car. I know that there are 20 cars on the lot, and I know that the mean value of the cars is 8,000. And knowing the mean value and how many there are, that's where this formula comes in really handy. If I know how many cars there are and I know the mean, then I can find the sum. Essentially, what's going on where with that formula is with a formula of pretty much any type. If I know all the components except for one, then I can find that missing one piece. And that's what we're going to do here. So let's see. Putting that formula to work, the mean, what value was 8,000. So I'll put 8,000 in for the mean. The sum of the values of the cars, that's the thing I don't know. So we'll put that up here. And then the number of cars I was told is 20, so I'll put 20 down here. And now I've gone from something that reads like, this might be kind of complicated. I'm not really sure what to do here. Well, wait a minute. Once we put this formula into use, it turns into a really simple equation for us to solve. Now, all we need to do to get sum by itself is multiply by 20 on the right, multiply by 20 on the left. These cancel, and I'm left with the fact that the sum is whatever 20 times 8,000 is. $160,000. So I don't know the value of any individual car in this car dealership, but what I do know is that if we add them all together, the total value is $160,000. Could be valuable for the owner of this car dealership or somebody who's writing an insurance policy for him. The key here that I want you to get is a problem that might not seem to have an obvious approach. When we put this formula to use, it's a really straightforward solving process. Let me know if you have any questions on that before I have you try one. And that's going to be kind of how today's going to go. We're going to do example, you try one. Example, you try one. That's what today's going to look like. Okay, here goes. A liquor store has 315 bottles in stock. The mean value of the bottles is $42. What's the total value of the bottles? I'll set up a poll for this and let you try it. Let's go another 20 seconds on this one, and then we'll talk through it together. Really straightforward application of the formula for the mean. Okay, let's see how we did here. Unanimous. Very good. That's excellent. Okay. So we read the question and we say, liquor store has 315 bottles. The mean value is $42. What's the total value? And it's obvious what approach to use because we just did one like it. But if you hadn't, you'd say, well, wait a minute. I know what the mean value is, and I know how many total bottles there are. And what I'm looking for is, even though it says total value here, really what I'm looking for is the sum of the value of all those bottles. And so kind of running through it in your head, well, wait a minute. If I know the mean and I know how many there are, and I'm looking for the sum, the formula that I know that relates the sum, how many there are, and the mean is this one right here, that the mean is the sum of the data points divided by the number of data points. And so that's how we kind of discover, oh yeah, this is one of those problems, is because of what do we know and what are we looking for? And those three pieces are the mean, the sum, and the number of data points. All right, so now let's go ahead and find the total value of these bottles. Let's see, the mean value was $42, so we'll put that where the mean is. The sum is what I'm looking for, the total value. And then there are 315 bottles in stock. That's the number of data points I've got. To get sum by itself here, we need to multiply by 315 on the right so that those cancel. If we multiply by 315 on the right, we also have to multiply by 315 on the left. And we find out that the sum, the total value of all those bottles, is just 315 times 42, or $13,230. The poll went great. You let me know if you have any questions on that one. All right, outstanding. Top of this one says using the formula for the mean, so you kind of have an idea of what's about to happen, but this is a different situation. Let's read through it. Josephine has taken 4 exams in her math class, and she has a mean score of 88. There's 1 exam remaining before her final grade is determined. What score will she need on the last exam in order to finish the class with an overall mean of 90? This one's not quite as straightforward as the last one, but we are given information here about the mean both times. And so when we see, talking about the mean here, so there's a pretty good chance that this formula with the mean being the sum of the data points divided by the number of data points might come in handy. So let's take a look here. In this situation, what's going on is Josephine's like, gosh, I am so close to having that A. What do I need to get on the last exam so that I'll finish the course with that A? And the way we're going to approach this one is we are going to look at how many points Josephine has earned up to this point. So up to now, how many points has she earned? Well, what we know about where we are right now is Josephine has taken 4 exams and she has a mean score of 88. So we could find the total number of points she's earned. We know her mean, we know the number, we could find the sum, which in this case is going to be the total number of points she's earned. So let's see here. Her mean score is 88. We don't know how many points she's earned so far. We'll call that the sum, but if you wanted to call that the points, that would make sense because that's what it is, how many points she's earned in the class so far. And then she's taken 4 exams. All right. Hey, this looks a lot like the last ones where we just multiply by that denominator on both sides. These cancel, and the sum, which here represents the number of points she's earned so far, is 4 times 88. 352. So as of right now, Josephine has earned 352 points in this class. I have no idea what any of her individual exam scores are. I don't know how she got here. I just know that If after 4 exams she has a mean of 88, then she has 352 total points so far. Let me know if you have any questions on what we did there to find her total up to now, those 352 points. Awesome. Now we have to figure out, okay, that's what she has now. Well, what is it that she's going to need? Well, she wants to have a mean of 90. So we're going to put 90 in for the mean. We're going to try to figure out the total number of points she's going to need. And here's where the rubber meets the road for this question. Here's the one thing in this one that might trip you up. What number is going to go down here? As far as that average of that overall mean of 90 is concerned, how many exams are we talking about? Jennifer, Shelby, you're exactly right. Celia, perfect. This is the key to this type of question is we need to make sure we put a 5 down here because after taking this one last exam, now we're not talking about a mean based on 4 exams anymore. Now we're talking about a mean based on 5 exams, and we need to incorporate that into our calculation. Okay, well, in that case, we'll go ahead and multiply by 5 to get those to cancel. And if we multiply by 5 on the right, we multiply by 5 on the left, and it looks like 450 is the sum she's going to need. So as of right now, she has 352 points. When that last exam is over, she's going to need to have 450 points. And so we're going to have to bridge that gap. We're going to have to get from 352 all the way to 450. We just need to subtract to find the difference between those, and that'll be the number of points she needs to earn on the last exam. So we'll do 450 minus 352, 450 minus 352, and she's going to need 98 points on that last exam in order to finish the course with an overall mean of 90. If you're thinking, wow, she has to be almost perfect just to pull her grade up from an 88 to a 90, just to pull it up those 2 points, she needs to be almost perfect. Well, we're going to talk about weighted averages later in the course, but the idea here is that these 4 exams that she took to have this 88 in place, that's a lot more powerful. That's a lot more potent than this one last exam. So she's going to have a really high score on that one exam to sort of counteract what happened on those first 4. And that's why she'll need the 98 on the last exam. Let me know if you have any questions about anything we did there before I have you try one. Awesome. Very good. Here goes. Carmen has taken 8 quizzes in her English class. She has a mean score of 72. There's 1 quiz remaining before her final grade is determined. What score will she need on the last quiz in order to finish the class with an overall mean of 70? So Carmen's looking at this the other way. Josephine was like, what do I need to get that A? Carmen's looking at this like, how low of a score can I get and still keep my 70? I'll give you some time to do this and I'll set up a poll for it. When you see a problem like this, your first instinct might not be to go straight to the formula for the mean, but keep in mind that mean is mentioned in here a couple of times. And so that's probably the place we want to go first is, okay, you're telling me about Carmen's mean score. I'm going to see if the formula for the mean is the right thing to do here. Because I don't think the mechanics of the solving process will be very hard for you, but I want to make sure you recognize, okay, this is one of those kind of problems where I'm going to use that formula for the mean. Let's go another 20 seconds on this, and then we'll talk about it. All right, let's see how we did. All right, unanimous again. Very good. That's excellent. Okay, so we'll go through this process. I feel pretty confident in your ability to solve it, but you let me know if you see something that you're unsure of or you're not, you don't understand why we did it. So what we're going to do is look at where is Carmen right now. Well, right now she's taken 8 quizzes and has a mean of 72. So 72 is her mean. I don't know how many points she's earned so far, but she's taken 8 quizzes. And I just put points in there instead of sum because that might be how you want to think of this one. It's really the sum of all of her quiz scores, but so you could use sum there. But I just use points in case you wanted to think of it in those terms. We'll multiply both sides by 8 so that we cancel those, and we can figure out the number of points that Carmen has earned so far is 8 times 72. 576 points so far. Of course, she wants to make sure she keeps that 70, so how many points is she going to need? Well, if she wants to finish with a 70, and a key here is how many points will that take if she has 8 plus this one more quiz, 9 altogether? So on 9 quizzes, to have a mean of 70, let's see, multiply both sides by 9, those cancel. The number of points she'll need is 9 times 70, 630. And so on that last quiz, she's got to get from 576 over to 630. To bridge that gap, we'll subtract to find the difference. And 630 minus 576 looks like she's going to need a 54 on that last quiz to keep her overall mean of 70. Same idea as the last one with Josephine. You might think, seriously? She's only got a 72 now. She's going to keep her 70 if she does this badly on the last quiz? Well, remember, there are 8 quizzes in the bank. That's a pretty powerful. That carries a lot of weight in this 72. So it's going to take a really low number to pull it down pretty far. And even if she gets a 54 on it, she'll maintain her 70 overall average because there's 8 of them in place carrying most of the weight. Let me know if you have questions on that before we look at another. All right. This one's a little different, and I'm actually going to approach this from a slightly different perspective. A morning section of a class consists of 18 students, and their mean score on an exam was 88. An afternoon section of a class took the same exam, and those 24 students earned a mean score of 81. What's the overall mean score for this exam? What you don't want to do here is say, well, there's an 88 and an 81. I'll just find the mean of those 2 numbers and have my overall mean. Why is that no good? And you don't have to be elegant about how you say it. I just want to know, well, I've got an 88 for my morning class and an 81 for my afternoon class. Can I just average those two numbers and that's the overall mean for the exam? Why won't that work? Very good, Shelby. You're exactly right. And Summer, you might say it a different way, and that's okay. But yeah, hearing it a different way could be really valuable for us. So if you were going to type something different, it's okay. The amount of students in each class, right? There are 18 students that got the 88. There are 24 students who got the 81. We don't want to treat it like they were exactly the same number of students. Instead, what we need to do is give proper weight to these. It might not be the first place where your mind goes with this, but this type of problem is a beautiful example of a place for us to use a frequency table. And the reason is we have 18 students that got 88. We have 24 students that got 81. So we have a whole bunch of data points that are the same as each other. And that's a great chance for us to use a frequency table. Here's what I mean. We have the score over here of 88, and then the frequency of that score was 18. There are 18 data points that are 88. Now, that's not exactly true. We don't know any individual student's specific score. But we do know if we add up all 18 student scores and divide by 18, that's an 88. So as far as how many points this morning class earned goes, it's really the same thing as if every single one of them in there earned an 88. So we can treat it that way as far as how many points were earned in the morning section. And we're going to see that in a minute. And then in the afternoon section, the mean score was 81, and there were 24 students in there. And now we've taken this, and the reason we can use a frequency table here is we have a whole bunch of this data point, and we have a whole bunch of this data point. So it works beautifully for a frequency table. And now we're back to what we did last class, where we just want to find the mean for this frequency table. Well, that we know how to do. Very important number is the total. 18 and 24, there are 42 total data points. That's our 42 students. And we'll go ahead and find the mean of this, just like we did on Tuesday. We'll say, well, then the mean here is going to be, there are 18 88s, there are 24 81s, and altogether there are 42 data points. Okay, well, 18 times 88 is 1,584. Before I go on, I want to talk about that 1,584 a little bit. What that 1,584 is, this is the total number of points earned in the morning class. I don't know what any individual exam score is, but I know that the mean in that morning class was 88, and I know that there were 18 students in the class. And so multiplying 18 times 88, which is exactly what we did here, would give us the total number of points earned in that morning section. So multiplying 18 by 88 there, putting this into a frequency table is exactly the same as adding up all of their individual scores. It's going to land at 1,584 total points. We do the same thing with the afternoon section then, 24 times 81, and get 1,944, because similarly, that's the total number of points earned in the afternoon section. I don't know what any of their individual scores are. If I did, I could add them all up. And I know it's going to arrive at 1,944 because the number of points earned by them is whatever 24 times 81 is. All right, now we'll finish this up and find our overall mean. We have 1944 plus 1584. That's 3,528 over 42. And we have an overall mean of 84. Your first thought might be, well, heck, 84 seems like that's about halfway between these two. Are you sure we couldn't just add those two up and divide by 2? Well, let's take a look at it. If I do 88 plus 81 and divide by 2 I get 84.5. Not the same thing as I got down here. Kind of makes sense that it's going to be a little bit lower than just taking these two numbers and taking the mean of them, because these 24 students that had this lower score is going to pull it down a little bit. Not a ton, because the difference in the score wasn't that much, but it does pull it down a little bit. And our overall mean on this exam is 84. I think it's pretty cool how that works out to be a frequency table question, even though at first glance it doesn't appear like that's how we're going to go about it. Does anybody have any questions on that one before I have you try one that's similar? Outstanding. Here goes. The freshman class at a small two-year college consists of 530 students. Their mean GPA is 3.6. At the same college, the sophomore class consists of 305 students, and their mean GPA is 3.0. What is the overall GPA for the students at the college? Remember, what we don't want to do here is say, well, halfway between those, 3.3, all done. Don't do that. Instead, this sets up beautifully for a frequency table. And that's all the hints I'll give you, and I'll let you try it. I'll go ahead and set up a poll for you. You can see that all of the choices in the poll have been rounded to the nearest hundredth. So that's what you should do when you solve this one. And this is one you don't necessarily have to use a frequency table, but I like tying it back to something that we're already comfortable with. You could approach this one from a standpoint that's very similar to what we did with Josephine and Carmen's scores, where you just sort of find out the total number of grade points that have been earned and divide that by the total number of uh, students, which is what we're going to do. But I think the frequency table really helps us streamline this a little bit when we have a whole bunch of data points that are the same as each other. That's why we point towards the frequency table. Let's go another 20 seconds and then talk about it. If you need more time, let me know. If you get an answer that's not up there, pick the one that's closest to yours. All right, let's take a look. Okay, not unanimous, but close. First one today, not unanimous, but awfully close to it. So let's take a look here. You let us know if you see something that you're unsure of, doesn't make sense. Why'd you do what you did there? So we read through it. Freshman class consists of 530 students, and their mean GPA is 3.6. Sophomore class is 305 students, and their mean GPA is 3.0. What's the overall GPA? You might not first think frequency table here, but I think what helps us do that is the idea that we have a whole bunch of data points that are the same as each other. We can treat this as though every single one of those students has a 3.6 GPA. That's not true. Some of them are 4.0, some of them are 3.0, some of them are 2.0, some of them are 2.71. But we can treat it as though they all have a 3.6 because that's the mean. That's what we would get if we added up all of their GPAs and divided by 530. Oh, awesome, Celia. That's fantastic. Now we are back to unanimous. Perfect. Um, so our data points here are the GPAs. And let's see, that 3.6 GPA, the frequency is 530. And then as far as that 3.0 GPA is concerned, that frequency is 305. And that's it. That's all the data in our frequency table. Well, heck, finding the mean of a frequency table, really comfortable with that. We need the total, which is 835 students altogether. And then if we want the mean, we're going to have 530 students that have a GPA of 3.6. We have 305 students with a GPA of 3.0. We'll divide by 835 total students. Be a little bit careful there. Remember how frequency table works. We don't want to divide by 2, treating it like we have 2 data points, because really we have 835 data points. All right, working through this then, our mean will be 530 times 3.6, 1,908. What that 1,908 is, if we added up the GPAs of all 530 students, we would get 1,908. So that's where the idea that some of them are 3.8, some of them are 3.2, some of them are 2.9. When we add them all together for those 530 students, we arrive at 1,908. Shortcut is, well, if we know their mean is 3.6, we can just multiply by 530, and that gives us the sum of their GPAs. Here again, we're using the formula for the mean, because the mean, which the mean of their GPAs being 3.6, we don't know what the sum of their GPAs is, but we know there are 530 people involved. I lost my connection here just for a second. Okay, there we go. We know there are 530 people involved. So when we multiply these two things together, that gives us the sum of their GPAs. And that's exactly what we've done here, multiplying those together to get the sum of their GPAs. You may not need that detailed of an explanation here, but I do want to make sure you understand what this 1,908 represents. And then similarly, when we do 305 times 3.0, that 915 also represents what we get if we add together all the GPAs of these 305 students. All right, then we'll divide by 835 and we'll have our overall GPA. So let's see, 915 plus 1,908, 2,823 divided by 835 is 3.3808. And it doesn't say it in the problem, but it was obvious to round to the nearest hundredth, so we'll go to the hundredth place, look one space to the right, that's 4 or lower, so we'll round this down to 3.38. So the overall GPA for students at the college is this 3.38. Remember, at the beginning of this, I said absolutely don't just take these two numbers and find the mean of those. It would be 3.3. Well, the reason we end up a little higher than 3.3 is because there's 530 students with this really good GPA and less students with this lower GPA. And so these 530 pull it up a little bit from the midpoint of 3.3, and it lands at 3.38. Let me know if you have any questions on that before we move on to a different type of question. Fantastic. Polls are going great today, so I'm thrilled. All right, using the formula for the mean. Here's a different type of question that reads a little bit complicated at first. The mean of a set of 8 numbers is 11. If one number is taken away, the new mean is 12. What was the number? Now, one of the things we did way back at the beginning of 122 was talk about there is more than one way to solve a problem. And if you wanted to do this with trial and error, you absolutely could. It'd be a little clumsy because we have 8 numbers involved, but you could do this with trial and error. However, when you read this and say, okay, you're telling me the mean and you're telling me how many there are. If you're going to tell me the mean and you're going to tell me the number of data points, then I can find the sum of those data points using this formula for the mean again. And I know we keep leaning in on that, but it's a really versatile formula, it turns out. Okay, then, the mean of a set of 8 numbers is 11. Okay, so the mean is 11. So you're telling me the mean is 11 and there are 8 numbers. So I'm not really sure where I'm going with this just yet, but I know that if I know the mean and I know how many points there are, I can find the sum of those. All right, well, let's do it then. I'm going to multiply both sides by 8. These will cancel. And so 88 is what I get when I add all those numbers together. So whatever was going on here, this mean of a set of 8 numbers is 11. If I add all those up, I get 88. Okay, let's see what the next part of this problem is all about here. The next part of this problem says, if one number is taken away, the new mean is 12. Okay, if one number is taken away, so if I take away one of the numbers, how many numbers do I have left? I know it's a simple question, but it's really important here. Kind of like when we looked at Josephine's tests and Carmen's quizzes. Very good, Shelby, Summer, fantastic. So if one number is taken away, now I have 7 numbers, and I know their mean is 12. All right, well, I'm just going to use this formula up here again, because again, I know the mean and I know how many there are. So the mean is now 12, and I don't know what they add up to, but I know there are 7 of them. Okay, well, let's go ahead and figure out then what that sum must be. We'll multiply both sides by 7. These cancel, and the sum of this new set of numbers that I have that only has 7 in it instead of 8, 7 times 12, that's 84. All right, so now I'm going to go back and make sure I understand this question and make sure I'm prepared to answer it. The mean of a set of 8 numbers is 11. That's what I've got going on over here. If a number is taken away, the new mean is 12. That's what I've got going on over here. What was the number? What number was taken away? Let me know. What number was taken away? And keeping in mind, I have no idea what the 8 numbers were. And I have no idea what the 7 numbers are, but I can figure out what number was taken away when I look at this information that I've got. Very good, Jennifer, Katie. I don't think this is easy at all. I think it's really easy to get lost in all this. It's so abstract. We were, up to now, we were talking about, cars at a dealership and liquor bottles in a store and exam scores and quiz scores and GPAs, and now all of a sudden it's this weird sort of abstract thing where the mean of a set of 8 numbers is 11. And if one's taken away, the new mean is 12. Wait a minute, I got to get my feet on the ground here. And how we do that is by putting this formula to work. All right, mean of a set of 8 is 11. That means the sum of those numbers was 88. I don't know what the numbers are, but there are 8 of them. And when I add them all up, I get 88. And I've taken away a number, and now I have 7 numbers over here. And the sum is now 84. Well, I don't know what any of those numbers are, but if the sum used to be 88 and the sum is now 84, then that means the number that was taken away had to have been a 4. I don't know what the other 7 numbers were, but when this thing started out, there was a 4 in there. I took it away because now I have this other data set where I add them up and get 84. I think that's harder than what we've done before, and it's because it's so abstract. You let me know if you have questions about what just happened there, and if we're comfortable, I'll have you try one. But the abstract nature of this makes it more challenging than what we've seen so far, no doubt. I think it's cool. I think it's kind of like a number puzzle, um, but doing this with trial and error would be so clumsy that I would never even want to try it. It doesn't have to be the middle number, Shelby. It's just one of them. We don't know what number it was. It's just one of them, right? So because we're just told, if one number is taken away, we don't know which number it is. So to get to 88 out of our 8 numbers, it could be, let's see, we could have 10, 20, 30, 40, 50, 60, and then I got to get to 88. So how about that gets me to 74, and that makes it, or no, that's still not enough, right? 10, 20, 30, 40, 50, 60. Yeah, that's 88 right there. And then I take this 4 away, and now I have 7 numbers that add up to 84. So, and we don't know if it's the first number, last number, middle number. It's just one of the numbers was a 4. That's all we know. Okay, perfect. Perfect. All right, let's have you try one. The mean of a set of 10 numbers is 43. If one number is taken away, the new mean is 39. What was the number? So when you read a question like this, I don't want you to start breathing heavy because it's so abstract, because it is. I want you to sort of think, okay, I'm going to have a process here. I'm going to use what I know, which they've given me the mean and they've given me how many, and that gives me a lot of power. All right, I'm going to let you try this one. I'll set up a poll for it. Because it's abstract, it's a little bit harder to get our heads around, but that's okay. When we think about what it is we actually know, that gives us a path to take towards answering our question. Let's go another 30 seconds on this one, and then we'll do it together. All right, See how we did here. All right, unanimous again. Unbelievable. This is really great. Okay, cool. Let's take a look at this one. So the first thing I'm told is that the mean of a set of 10 numbers is 43. And again, just to sort of walk back through our process here, I know the mean and I know how many there are. I know something that connects those things together, and it's this, and that's going to allow me to find the sum of those 10 numbers. So the mean is 43, and I don't know what the sum is, but I know there are 10 of them. So I'll go ahead and multiply both sides by 10, and that'll let me know that the sum of these 10 numbers is 430. I have no idea what any of the numbers are. It could be 422 and a whole bunch of ones. I don't know. I don't know what the numbers are. I just know if I add them up, I get 430. Then the second part of this question says, if a number is taken away, so now I only have 9 numbers, and of those, the new mean is 39. So my mean is going to be 39. I don't know what they add up to, but I know there are 9 of them. And in order to find that sum, we'll multiply both sides by 9. These will cancel. And the sum of this set of 9 numbers is whatever 9 times 39 is. 351. So in the old set of numbers, there were 10 of them, and it added up to 430. In my new set of numbers, there's 9 of them, and it adds up to 351. So something's been taken away to reduce it that much. And I just need to subtract to figure out what that is. 430 minus 351 is 79. So the number that was taken away was 79. I don't know what any of the 9 other numbers are. I just know that there used to be a 79 in here. That 79 was taken away, so now they add up to 351. Let me know if you have any questions about that before we look at the next one. Fantastic. Really good. Okay. Kenny took 3 tests. Okay, we're back to something concrete again. So we're not abstract anymore. Kenny took 3 tests. The mean of his scores was 83. The median score was 86, and the range was 21. What were his 3 scores? Okay, so here we kind of have a number puzzle, but it is something that's very real for us. So he took 3 tests, and the question is, what were his 3 scores? And the way that I'm going to label these is he's going to have a high score, a middle score, and a low score. You could label them differently, but I think that's really helpful here, partially because they tell me one of these right away. Which one of these do I know already for sure? The high, the middle, or the low? And what will it be? Perfect, Jennifer. Thank you, Shelby. That's exactly right. We know that the median score was 86, so we can put that 86 right here already for sure. If you tell me the median's 86 and there's 3 of them, that has to be the one in the middle. So his middle score is an 86. All right. I need to know all 3 scores though. And I'm told that the mean was 83. Well, here again, I know the mean and I know how many there are. So I can use the formula for the mean here. The mean was 83. I don't know what the sum of his exam scores were, but I know he took 3 of them, so I can find it. We're going to multiply both sides by 3. These cancel. And so the sum of his exam scores is whatever 3 times 83 is. 249. All right. So here we go. Now I'm at a place where I know the sum of his exam scores, and I know the range is 21. At this point, you could kind of do some trial and error, but I don't think I want to go there just yet. I know if I add up all 3 scores, I get 249. But I know one of the scores is 86. So how about we subtract that one off of there? And so then I'm going to subtract that 86. 249 minus 86. And 163 must be what I get when I add the highest plus the lowest. Is that all right? Let me know if you disagree with anything I've done or if you don't really see where it came from. That if I know all three scores add to 249 and I take this 86 away, then the other two scores must add to 163. That's what we're saying there. We're comfortable with that? Okay, I'm going to make myself some space and jot that down over here on the side. So high plus low is 163. The other thing I know that I haven't used yet is the idea that the range is 21. Well, the range is the highest minus the lowest. That's what the range means. So I can also say that the highest minus the lowest has to be 21. Now we're at a place where, hey, wait a minute, I have two equations and two variables. That means we can use substitution. This has suddenly turned into a pigs and chickens problem. Those of you that had me for 122 know exactly what that means. We also kind of looked at it the first day of class this semester too. So a pigs and chickens problem, you could solve this with trial and error, absolutely. You could say, what if the high was 90 and the low was whatever 21 less than that is? And then modify your numbers a little bit till you get to the right thing. There's nothing wrong with trial and error. It's a perfectly reasonable way to go. You could say, and I don't want this to work, but if you said the high was 90, and then since the range is 21, if the high was 90, then the low would have to be 69. Does that work? And if it does, great. If it doesn't, then you modify those numbers a little bit to get them where you need them to be. Instead of that, we're going to solve this using substitution. And what I mean by that is whenever I have two equations and two variables, we can rearrange one so that we can write this as one equation with one variable. I don't like having negatives anywhere. So my thought here is I'm going to add L to both sides of this one. Those will cancel, and I can see that H is going to be 21 plus L. It makes sense. The high is going to be 21 more than the lowest. And then what I'm allowed to do here is say, well, wait a minute, since H and 21 plus L are exactly the same thing, I can take 21 plus L and put it in that other equation where the H is. And that's exactly what we're going to do. We're going to say, instead of H plus L is 163, we're going to say 21 plus L is 163, and we're going to solve that one. I've got like terms in here. That L and this L, I can go ahead and combine those. And so 21 plus 2L is 163. Now we have to solve this equation. And I apologize if this is a review for you, but it may not be a review for everybody. So I think it's worth the effort. We're trying to get this L by itself. So we need to get the term that has L in it by itself. So as we look at this entire left side of the equation, we need to peel it from the outside in. We're going to get rid of that 21 first. How am I going to get rid of that 21? What am I going to do to both sides? Perfect, Katie. Thank you very much. We're going to subtract 21 from both sides. Those will cancel, and now I have 2L is 163 minus 21, 142. Finally, we're going to divide both sides by 2 to get the L by itself, and L is 71. So I just found out that the lowest test score is 71. I still need the highest because I was supposed to find all three. I can do this a couple of different ways, but I think the simplest is probably to look right here and say, well, the highest is going to be 21 more than that. So if that's 71 and I add 21 to it, the highest is going to be 92. And so the question said, what were his three test scores? There they are, 92, 86, and 71. A really nice thing about a question like this one is it's easy to check, right? The mean of his scores was 83. Well, let's see. 92 plus 86 plus 71, divide by 3. Sure enough, mean was 83. The median was 86. Yep, got that. And the range was 21. Is this 21 bigger than that? It sure is. I've met all the conditions of the problem, so I know it has to be correct. Let me know if you have questions on that before I have you try one. I think it's a really cool question. The key here is start with the median and then use the idea that you know one of the scores to figure out what high plus low has to be. All right, let's try one. Peyton took 3 exams. The mean of his scores was 90, the median score was 89, and the range was 11. What was his highest score? Now, I kind of want you to find all three of them, but as far as the polls go concerned, I'm just going to put the highest in there. I'll set up a poll for this. I understand that this takes a little time. We don't have to be in a hurry here. So what I want you to do is be patient with yourself, take some time, and find out what his 3 scores were. And then as far as the poll goes, let me know what you find to be Peyton's highest score. When you get to the point where you know the median and you know the sum of the scores, it's okay to use trial and error to find the highest and lowest. I encourage you to use the algebra that we did there using substitution to replace one variable with uh, the other. But if you want to use trial and error, it's okay. And if you're kind of thinking, those last two, that one that was pretty abstract there, where if you take a number away, that was harder than what we did at the beginning. And then this one's a little bit different than that, but kind of challenging in its own way. If you're thinking, how hard are these going to get? That's fair. This is the top of the mountain. This is it. This is the most challenging type of formula for the mean question we'll see. Let's go another 20 seconds on this one, and then we'll talk about it together. Just like always, if you get an answer that's not shown there, you could pick can't tell, or you can pick the one that's closest to yours. Either way is all right. All right, let's see how we did. All right. I think we were unanimous all the way through today. That's incredible. That's really great. Okay, let's go ahead and take a look at this one. Since you did well on it, I won't over explain unless you ask me to. Peyton took 3 exams. The mean was 90. The median was 89 and the range was 11. What was his highest score? Well, we're going to go ahead and find all 3 of those. The highest, the middle, and the lowest. We're told that the median score was 89, so we know that's the one in the middle. And then since the mean of his scores was 90, and we know he took 3 exams, we can say, okay, then his mean was 90, and he took 3 exams. So we'll multiply both sides by 3, and 270 is the sum. So if I were to add up all 3 scores, I'm going to get 90, or excuse me, 270. Well, I already know that one of the scores was an 89, so I can kind of take that out of there. And I could say, well, if I do 270 minus that 89, then the other 2 scores, 270 minus 89, the other 2 scores have to add up to 181. So I get one of the 2 equations I need here. The high plus the low has to be 181. Well, but if I have 2 variables, I need 2 equations. What's the other equation going to be? That's kind of hidden right here when I'm told the range is 11. If I'm told the range is 11, that means the highest minus the lowest has to be 11, the difference between the 2. Now I can see, hey, wait a minute. I've got 2 variables and 2 equations. I can use substitution and then solve this thing. Like I said, you could also use trial and error and say, well, what if the high was 90 and then the low had to be 79? Would those 2 add up to 181? No, they don't. I need to modify this a little bit. There's nothing wrong with trial and error. But just to show you the algebra, we'll work through it that way. What I'm going to do here in order to use substitution is get rid of that negative by adding L to both sides. So H is just going to be 11 plus L. What that means is in the other equation, wherever I see a H, I can put 11 plus L. So I'll have 11 plus L is 181. So 11 plus 2L is 181. We're going to subtract 11 from both sides so that 2L is 170. And then finally divide both sides by 2 so that L is 85. What I've just found is that Peyton's lowest score was 85, and that's valuable for me. That's good to know. But this poll asked me what's the highest score, so I need to get that. Well, if I know the highest is just the lowest plus 11, then 85 plus 11 means the highest must have been 96. And the poll asked for his highest score, which sure enough is 96. But if we found all 3, the highest was 96, the middle was 89, and the lowest was 85. That gave him a mean of 90, a median of 89, and a range of 11. Any questions on anything we did there on that one?